Hi, I'm Jeff Hajek, the owner and founder of Velaction. This video is part of my lean training system. It was originally released as a DVD a long time ago, but times have changed and the look of some of these LTS videos is now a bit dated. The content is still spot on though, so rather than just discontinue the line, I am posting the majority of each of the 36 videos here, with the remainder available at Velaction Videos. That's our video service where you can download a wealth of supporting content and watch subscriber-only videos. I recommend subscribing and hitting the notification button if you want to make sure you don't miss any new content. I would also really appreciate if you would hit the like button if this video is helpful and you want to see more content similar to it. The like button helps us get found on YouTube, but it also lets us figure out where you want us to put our future effort. Now enjoy the free version of this video. Welcome to Velaction Continuous Improvement's overview presentation on quality. I am Jeff Hajek, the owner and founder of Velaction. Let's start out by covering a few of our main goals for this presentation. First off, I'd like to cover a more detailed definition of quality, which would include the various ways it can be viewed. Second, I would like to talk about how quality can be quantified. And finally, and most importantly, I will talk about general philosophies for improving quality. When I say quality, most of you will immediately think of a specific way of interpreting that. Some of you will think of grade. This is the difference between top-of-the-line models and economy classes. It's Mercedes versus Hyundai. This form of quality is based heavily on reputation. The reputation may be based on fact, but because it is a perception, the grade of a particular product can change even if the product itself remains constant. The second way you may have thought of quality is in terms of application. We often think of something as being a quality product based on how well it solves our problem. Obviously, a pickup truck is more suited to hauling mulch than a luxury sedan would be. But we also tend to assign quality based on how well an item performs. A top-of-the-line smartphone with a short battery life will take a quality hit. When asked about how you thought about quality earlier, most of you probably thought of this last category. Conformance to spec simply means that the product is built as intended. It is worth mentioning that there is a potential for conflict between companies and customers in this area. A company may build a product 100% in accordance with its plan, but it still may not meet the expectations of the customer. This is often a result of inflated marketing expectations. Think of the old-time ads in the back of comic books. Kids thought they were getting some magical city of sea monkeys. What was really shipped was far different. That product, however, probably was packaged according to plan. The point? Even if the manufacturing side of the company does everything exactly right, customers will still hold you accountable for meeting the published specs. There is a great deal of overlap and influence between these categories of quality. A short battery life, if the customers expect that short battery life, will be an application failing. If the short battery life does not match what the company publishes about its phone and its marketing materials, or if the battery does not meet its design specs from the vendors, it is a problem with the conformance to spec. Regardless of the source, that short battery life will tarnish the reputation of the product, lowering the perception of grade. I hope you are getting something valuable out of this video. If you want to get more out of this program, we recommend watching it on Velaction Videos. You'll be able to watch the entire video, mostly ad-free, and view subscriber-only programs. You'll also have access to a load of continuous improvement downloads. This seems like a fairly straightforward question. Most people will jump to one or even several reasons that quality is important. Most of these will be traceable to the bottom line. Poor quality impacts profit. Higher quality often means you can charge more and also sell more. But even in cases where quality does not increase sales, there is still a financial impact. That is because there is a cost to poor quality. The cost of poor quality is the aggregate of all the resources a company spends to make things right when they mess something up. Obviously, if there is a cost to poor quality, there is also a benefit to good quality. We often think of quality as being expensive. In truth, though, good quality generally speeds up processes. Poor quality makes people tentative about the components they're using, which results in more checking and testing. If you have faith in the parts and processes you are using, you can generally fly through your work. There is also a big benefit to eliminating friction between employees. Think of most conflicts on the job. I'm not talking about personality issues or simply not liking each other. I am talking about issues where one person is at odds with another over work that was performed. A person working in a downstream process may become frustrated when he has to continuously deal with defects in the work he receives from an upstream process. Lean organizations thrive on teamwork. That teamwork is hard to establish when leadership allows poor quality to be passed on. When I say cost of poor quality, several things probably immediately come to mind. Things like rework, inspections, scrap, and additional materials to compensate for problems are all obvious costs that come from not doing things right the first time. But there's also a slew of other problems that come from quality issues. Marketing gets harder when you develop a reputation for poor quality. Production teams have to set up entire systems to deal with recurring issues. Workers across the company spend their valuable time managing problems. This often requires numerous meetings and other forms of communication to resolve issues. The customer service team becomes inflated. Shipping delays require expensive expedited shipping to compensate. Teams become stressed out dealing with problems and the associated conflicts that result in low morale and an increase in the management oversight that comes from a team that is not working together well. The point of this slide is to highlight the pervasiveness of the costs that come from not doing things right the first time. Obviously, poorly made products are harder to sell. That means they act like an anchor on the growth rate of the company. Why does this matter? In the modern world, small businesses can survive in a static situation. A mom-and-pop shop can do the same business year after year and be happy. This is not the case as a company becomes larger, and especially if it is looking for investors. This simple image shows how a company is valued. The current value of the company, reflected in stock price for publicly traded companies, is basically the value of what the company currently owns, plus an estimate of how much it can make in the future using those assets. If the projection for future growth is high, it is reflected in the value of the company. If quality is poor, investors' estimates of that growth will be lower. That means they will be willing to offer less money for an ownership stake in a company. Now, many employees will think of this as rich people problems. They may not worry about expansion plans in Europe if they feel like their job in Tucson is safe. What they miss, though, is that when companies do well, life tends to be easier for employees. A large, successful company can invest in creating stronger systems. They tend to have more resources to invest in improvement and in things like research and development and employee retention programs. Successful companies are also less likely to cut corners. They focus on doing things the right way, which leads to better quality. All of these things can have a positive impact on frontline employees. As part of the Lean training system this video comes from, we offer a variety of Lean Lego training packages. These include our Lean Lego flow simulation, mistake proofing or poka-yoke Lean Lego exercise, and our visual controls and 5S Lean Lego exercise. We've also got an office flow simulation for those not implementing continuous improvement on the shop floor. Click the links in the description below or click on cards that pop up on this video to learn more. We'll also add links at the end. Let's shift gears for a moment, and instead of looking at quality from the company perspective, let's think about how customers behave regarding quality. The first thing to note is that perception is reality. When people think about a car manufacturer that is synonymous with quality, they either think of high-end luxury manufacturers like Mercedes and Lexus, or they think about cars that don't have problems. Toyota is the manufacturer that most people link to that definition of quality. The truth, though, is that other car manufacturers have caught up to Toyota in the J.D. Power's initial quality survey. In 2014, Hyundai actually beat Toyota by a significant amount. Still though, Toyota bears the title of quality leader, and Hyundai is looked at as a low-end manufacturer. The point here is that customers don't always rely on facts and data to make their decisions. Their opinion about quality is just as likely to guide their behaviors. What this means for you is that quality issues that damage your reputation can be extremely hard to overcome. A second way that customer behaviors will affect you in terms of quality is that they will hold your company responsible for everything associated with your product. Airlines get battered by their customers whenever there is bad weather, throwing a monkey wrench into travel plans. Customers are also intolerant of companies that pass the buck and blame their vendors for quality issues. A computer manufacturer will not be let off the hook if they choose to use hard drives that fail at too high of a rate. To some degree, companies are also held accountable even if the product is misused or mistreated, but in a foreseeable fashion. Phones are probably not intended to be sat upon. It is quite foreseeable, however, for people to place them in their back pocket and forget they are there when they sit down. If your phone bends in those conditions, your customers will likely blame you rather than themselves. The point is that companies must be aware of how their products will be used and make sure that their image of quality is protected even in adverse situations. Delays in shipping are often held against the manufacturer, even if it is not their fault. Similarly, computer companies are often raked over the coals by their customers for compatibility issues, regardless of where the problem lies. Dealing with this means that companies have to be very careful about the partners they choose. Using cut-rate vendors may help with traditional accounting measures where unit cost reigns supreme, but it might not be the best choice for long-term success. The bottom line is that the business environment is not always fair. Customers will hold you responsible for things that are not your fault. Good quality means planning for those situations. While quality can be quite subjective from a customer point of view, it is important to take a quantitative approach to any quality improvement program. So how is quality measured? Let's look at a few common metrics. Yield is the percentage of work that passes through a process error-free. Basically, it is the inverse of the defect rate. Keep in mind that yield is often artificially high because corrective action is taken on the spot. In some processes, there is a significant amount of inline rework that is never seen on any quality metric. PPM, or parts per million, is a normalized measure that was popularized by Six Sigma. It is commonly used as a measure of the number of defects per million units. Customer satisfaction is another way that quality is measured. While this is important, customer satisfaction needs to be taken in context. First of all, it is very qualitative and subjective. You have to define what customer satisfaction is. Then, you have to assign some kind of scoring system to that. Finally, you have to devise a way of collecting that data. The problem with any opinion-based customer satisfaction score is that people only tend to give unsolicited information or respond to surveys when they are either extremely happy or extremely angry with what you are doing. It is a challenge to get an accurate understanding of that middle range of customers. Scrap rate is another metric that is often used related to quality. It is similar to yield, however it focuses on those components that can no longer be used. In effect, you are looking through the trash heap to see what did not make it into your final products. One of the problems with scrap is that it is not just the cost of the defective or damaged product that you are dealing with. In most cases, you only identify the problem after it has been installed onto the item you're building. That means labor costs can be significant depending on how much work installing and then replacing the component takes. Let's look at yield in a bit more detail. Imagine you have 4 processes that are linked together. Each of them seems like they have a relatively high percentage associated with them. If you were in grade school, on many scales, this would make you a straight-A student. But if you look at all these linked together, you are dealing with something called rolled-through yield. When you multiply all the yields out, you'll find that the work entering step 1 has a 1 in 4 chance of having problems along the way. To get great results, you have to have extremely high yields at every single one of your process steps. the effective roll-through yield is magnified based on the number of processes your work goes through. Even seemingly reasonable individual yields will result in a large percentage of your production items needing rework at some point along the way. And keep in mind that the greater the number of problems you have within your processes, the larger the chance you will have of a defect escaping to the customer. Let's take a closer look at the parts per million metric. Again, ppm is a term that was popularized through Six Sigma, and it refers to a normalized way of looking at defects. You may also see a variation on this known as ppmo, meaning parts per million opportunities, or dpmo, meaning defects per million opportunities. Instead of focusing on the number of units, you look at the total number of opportunities to make mistakes on those units. Consider something like jet planes. There are a relatively small number of 747s that are built. It is unlikely that any of them are built perfectly, considering that they have something like 6 million parts on them. That means that a plane with 5,999,000 good quality points and one bad one would have a huge impact on ppm. Looking at the total number of opportunities compensates for situations like this where there are just a small number of units. So, what is a sigma? In short, a sigma is a standard deviation. It is a measure of spread of a distribution. Basically, how far all of the measurements in question vary from the average. In Six Sigma, we are referring to the ability to have 6 standard deviations fit within our specifications. For reference, with one standard deviation, 308,000 out of a million items would be out of spec. That number drops to 3.4 out of 1 million at Six Sigma. Very few items actually achieve Six Sigma quality, though. It is something only slightly less challenging than finding the holy grail of quality. So let's think now about how a defect actually occurs. Whether this happens within your own walls or the walls of a vendor that ships you a defective component, the mechanics are the same. There is a linkage between an error and a defect. Every defect is caused by an error in a process somewhere. That error can be systematic to the process, or it can be a result of a process not being properly followed. Regardless, something is done that is not intended. That mistake, if not identified and fixed, leads to a defect in the final product. Not everything is as simple as it seems, though. In some cases, you may make an error that on its own will not lead to a defect. Sometimes, defects are the result of multiple errors happening at different steps of a process. Perhaps a hole is drilled wrong on a metal plate in step 1, but it will only cause a problem if the plate is also installed backwards in step 3. In those cases, it is the combination of multiple errors that create the defect. As you can probably expect, these type of problems are both more difficult to identify and more difficult to resolve. This video comes from Velaction's Lean training system, which takes a module-based approach to learning about continuous improvement. Modules include a PowerPoint presentation and student guides for every video, plus there are many exercises and quizzes as well. There's also a whole host of supporting content in the form of terms in our Continuous Improvement Companion and downloadable articles. Our modules are currently available in our store and as downloads at Velaction Videos. Click the links in the description below or click on the cards that pop up on this video to learn more. We'll also add links at the end. Understanding quality is only part of the challenges you will face. Even if you have deep knowledge of what your problems are, you will still have to do something about them. Those things that you can do are located on a long spectrum. The least sophisticated way of dealing with quality issues is simply to react to the defects. If a customer complains about a problem, you allocate resources to fix or replace the defective product. Another fairly basic way of managing quality is to inspect your own work. The challenge here is what you might expect. If you miss the problem the first time while you're assembling the product, there's a high likelihood you will miss it the second time while you're inspecting it as well. Plus, this is one of the most likely steps to be skipped when a frontline operator is running behind. A more effective way of dealing with quality issues is the end-of-line inspection. This is generally done by a separate person who has a checklist that they run through to make sure that the item is built to spec. Generally, the larger and more expensive the item, the more thorough the end-of-line inspection will be. And keep in mind that thorough tends to also mean expensive and time-consuming. One of the reasons that end-of-line inspections are expensive is that additional work was added on top of the defect before it was found. That means that more rework has to be done to fix the problem. Successive inspections are meant to deal with this issue. The downstream process inspects the work of the upstream process. One big benefit here is that the work is still close to the person who made the error. They can be called over to fix the problem quickly. Being accountable for fixing your own mistakes goes a long way towards creating a culture that is focused on good quality. But all those ways of improving quality pales in comparison to building good quality into your processes. Make the processes bulletproof. Make them hard to make a mistake with. This is often accomplished by using mistake-proofing or poka-yoke devices. Poka-yoke is simply the Japanese term for mistake-proofing. Let's talk for a minute now about how your continuous improvement efforts factor into your quality planning. Of the three forms of quality that we talked about earlier, lean has the biggest impact on conformance issues. To be clear, lean will still benefit the other forms of quality. For example, your design team can use lean to get better at rolling out new high-end products. But those benefits are not exclusive to the top-of-the-line stuff. Economy-grade items also benefit from those same process improvements. Conformance, though, is right in lean's wheelhouse. It improves your processes and reduces defects. Keep in mind that quality is not isolated to just the shop floor. Your continuous improvement efforts will also have a big impact on your administrative processes. The sweet spot of lean, though, is building quality into processes. Of course, reducing inventory lowers the impact of poor quality and helps you uncover issues sooner, but those problems are both just amplifications of poor processes. There are many tools in your lean toolkit. Let's talk about how these tools impact quality. The first tool I'll talk about is standardization. Variation is the bane of quality. You can't expect consistent output if you are using a different process every single time. Standardization also has another big benefit. It makes problems jump out at you. When something is out of the ordinary, it becomes highly noticeable. And if problems are easy to notice, presumably you'll do something about them. There are also some leadership tools that will significantly improve your quality efforts. Daily management is a leadership-oriented PDCA cycle in which you make a prediction about what you will accomplish in that day. You then compare your actual performance to your estimate. If something is wrong, you identify it and deal with it right away. This means the process won't be allowed. Thanks for watching this extended free version of our Lean Training System module video. If you want to watch the whole video, check it out at Valaction Videos. If you want to make sure you don't miss the next LTS video that we post, please be sure to subscribe down below. We also always appreciate likes as it helps us get viewed more and makes us keep adding additional content. Thanks for watching, and best wishes on your continuous improvement journey.